In this video, we will be solving problems with trigonometric ratios. Here's example 1. An outdoor fireplace deck has the shape of a regular hexagon. The distance from one vertex to the opposite vertex, measured through the center of the deck, is approximately 2.4 meters. There is a strip of thin bricks around the edge of the deck. What is the total length of this strip to the nearest tenth of a meter? To determine the length of the strip, calculate the perimeter of the surface of the deck. Since the surface of the deck is a regular hexagon, congruent isosceles triangles are formed by drawing line segments from the center of the surface to each vertex. We will isolate one triangle and find the length of its base. Multiply by 6, we should have the needed perimeter. In each triangle, the angle at the center is 360 degrees divided by 6, so it's 60 degrees. The line segment from the center of the hexagon to the center of each side of the hexagon bisects each central angle and is perpendicular to the side. We end up with a triangle as so. Triangle ADB, but inside that we have triangle ACB. Notice the 30 degrees. Bisecting means to divide into two equal parts. So the 60-degree angle was bisected into two 30-degree angles. We also know that DC equals BC. Recall that we need the length of DB, which is really twice the length of BC. So in right triangle ABC, we have angle A equals 30 degrees and AB equals 1.2 meters. Since we are looking for the opposite and we have the hypotenuse, we choose to use sine. Sine 30 degrees is the opposite, which is BC, divided by the hypotenuse, which is 1.2. Letting BC equal A, we now solve sine 30 degrees equals A over 1.2. We can write this as sine 30 degrees over 1 equals A over 1.2. We can cross multiply 1 times A equals 1.2 times sine 30 degrees. We have A equals 1.2 sine 30 degrees. This gives us A, which is the length of BC, equals 0.6 meters. Therefore, BD equals twice BC, which is twice times 0.6 meters, which is 1.2 meters. Meaning that the total length is 6 times the length BD, which is 6 times 1.2 meters, which is 7.2 meters. The total length of the brick strip is 7.2 meters. Here's some practice. Diego is designing a bicycle ramp for his BMX friends using plywood. The height of the ramp is 2.0 feet and the angle of inclination of the ramp with the pavement is 9 degrees. A typical sheet of plywood is 8 feet long and 4 feet wide. Does Diego need more than one sheet of plywood if the width of the ramp is exactly the width of the plywood? You may wish to hit pause here and try this on your own. Here we have our opposite and we need our hypotenuse, so we choose to use sine. Sine of 9 degrees is the opposite, which is 2.0 feet, divided by the hypotenuse, which we will let equal h. This gives us sine 9 degrees equals 2.0 divided by h. Writing this as sine 9 degrees over 1 equals 2.0 over h. We cross multiply to get 1 times 2.0 equals h times sine 9 degrees, giving us h sine 9 degrees equals 2.0. Isolating for the variable and dividing both sides by sine 9 degrees, and canceling the sine 9 degrees on the left-hand side, we get h equals 2.0 divided by sine 9 degrees. We take our calculator and 2.0 divided by sine 9 degrees is 12.784,90644 continuing. Rounding to the nearest tenth, we get h equals 12.8 feet. Since the length, which is 12.8 feet, is greater than 8 feet, Diego needs more than one sheet of plywood. Please proceed to the next activity in this lesson, and thank you for viewing.